o'clock it will be starting.
So we can discuss about if we're going to meet. It's a round table thing.
Okay.
Turning the tables.
Yeah, I think so.
It's with you today at
No, not with me. Not with me.
I have a meeting here today with someone about turning the table.
Yeah.
Okay, because it will happen tomorrow.
Okay.
I want to know now. I feel honored and I feel lucky to be here. For me, it was kind of surprise because in order to be in these meetings, you cannot make yourself a candidate. Someone has to make you a candidate. And for me, it was like some a chain party from Germany made me a candidate, and then I was happily informed. Then I have to fill a profile or something on the internet because there are so many filters. They start with 25,000 young research all around the world. They go after to 1,500, and at the end is 500. But yes, I was basically lucky. I'm doing some research with stem cells in Germany, in Freiburg, south of Germany. So I guess they really like how I can combine the clinical part, being a neurosurgeon, but also the experimental, now trying to be some more scientific group, work now in the laboratory. Yes. Our strategy is to replace neuronal population that's die because of the history, a normal history of a neurodegenerative disease like Parkinson and Huntington, where you have a lot of neural population. So our strategy is to replace this neural population with stem cells. So for example, here you can see some stem cells. We take the stem cells out of embryos. These embryos come from a voluntary termination of the abortion. We do not produce embryos, we just use it like an organ donation. And then we make some steps to convert the part of the embryo who is going to develop the dopaminergic neurons and convert it again in cells and then transplant it into the brain of patients with Parkinson or Huntington. Well, ethics has been always important in research because research just always start doing experimental work in animals. And then the first question is, how can you prove that there's this experimental work which is performed in animals and not in humans could be applicable to humans? This is the main concern in ethics. Historically, you can see how, for example, in order to take these experimentals from animals or any clinical experimental to humans, it can last 20 to more years in order to come to be useful in humans. But so far, there are two things that the public should know about working with embryos. The first one is that you can work with embryos produced in vitro, and you can also work with embryos that come out from voluntary termination of the pregnancy. And this is different. When you start working with in vitro embryos, then you can have many embryos to work with. But when you work with an embryo come of a voluntary termination of the pregnancy, then it works just like an organ donation, and you are able to help someone, like in the case of the transplantation, with this donation. It works just like an organ donation.
We have, in order to prepare this, we, just by email, will have a first of two, what we call
means that there will be a possibility of an identical person being with personalized medicine.
Well, you know, many of the Nobel laureates are friends. We go to similar meetings all over the world, and it's fun to see them again. But another important reason is to meet with all the young people. The young people are curious, exciting to talk to. It's a lot of fun. I enjoy that. That's why we become teachers, I think.
In the DNA, these are errors of replication or accidents happening to the DNA. I wanted to invite you to give up that idea works. And in order to see how that works, we have to think, how do we investigate that? On the lower part here in red, I say individual processes of the generation of genetic variants is available. These are entire genomes, but you could also be interested to look in individual genes or
which are behind evolutions, if I may say so, of chemistry these days. You don't need to see the structures, it's not so important, the details of the molecules, but what is behind them.
Link these components together by reversal bonds and let them run. Let them do something, let them assemble. One can therefore make what we call DNAs, dynamic nucleic acids, where the basis, where they can generate polymerized entities, which are analogs. Beyond that, molecules can be organized into larger entities of supramolecular nature, and this is...
so little pieces that can be packed around gives you the chance of covering a greater area.
Some magical tricks we're doing. Some code. Yeah.
I would like to insist that there is a gap of miscommunication between the science, the public, the politics. And this is where the problems are created. So regarding religion, for example, there are some countries where more religion tradition, where working with the stem cell or talking about cloning, it could be playing God and it's not allowed. But once you give the right information that the stem cells at this moment are curing people from leukemia, for example, or it could be opportunity to cure people from diabetes, then they maybe could see that this is helping people and not harming any human being. As long as you don't have research, then you don't have legislation. So there are a lot of countries that doesn't have really legislation for stem cells, for example. So it's not allowed, but it's not forbidden also. So I think we should make more channels to make people understand what it is. But the problem is that the countries doesn't have research, the people maybe is not that much interested on it. So here the media also plays a really important role, and the politics has to deal a lot with money for research. So it's really important the power of politics and research in countries like the United States or the European nation, and it's not that important in some other developing countries because there is not money at all for research. For us, ethics, we always need some ethical permissions to do procedures. So as long as there is an ethical concernation, we have to go and make meetings of people to decide if something is ethical or not. So for our everyday job is everything about ethics. We also do some kind of procedure who are called deep brain stimulation. It's putting an electrode into the brain of a patient in order to change behavior, for example. So we can make surgery for anorexia, we can make surgery for depression, for aggressivity, but then you have to come together a group of people, psychiatrists, people, external people, neurologists, to make a decision if it's ethical or not to make an intervention of this person. And now if you go further, of course, for the stem cells, there is always some kind of moralistic impedition because they say, okay, if the embryo comes out for an abortion, is abortion legal? The mother of the kid should not do this, for example. There are many countries in Latin America, almost all, where abortion is illegal. So as abortion is illegal, you cannot even speak about working with embryos. So, yeah.